Hello everyone, a very good afternoon to one and all present here. Hope you all are doing well. It is our pleasure to welcome you all to the 7th International Conference on Smart Trends for Computing and Communications, SMARTCOM 2023. The main aim of this conference is to provide an opportunity for professionals and researchers to present their research findings, to gain experience in the field, receive valuable input from experts about how to strengthen their work, and disseminate exciting and cutting edge findings from their field of study. And now, to start with the formal session, I would like to invite Dr. Amit Joshi to address the inaugural session. Dr. Amit Joshi is the organizing secretary of SMARTCOM 2023 and currently the director of Global Knowledge Research Foundation. Dr. Joshi has an experience of around 10 years in academic and industry in prestigious organizations. Currently, Dr. Joshi is the International Chair of InterVIIT at International Federation of Information Processing, IFIP, Austria. He has presented and published more than 50 papers in national and international journals, conferences of IEEE and ACM. Dr. Joshi has also organized more than 50 national and international conferences and programs in association with ACM, Springer, and IEEE, to name a few across different countries, including India, UK, Europe, USA, Canada, Thailand, and many more. Dr. Amit Joshi, over to you, sir, for your further address.
Thank you, Anisha, for a wide introduction. I am not used to such introductions, but still, thank you so much. And I welcome all the participants to the 7th International Conference on Smart Trends for Computing and Communications. So we have moved our journey and we are now entering into the 7th consecutive year of the SmartCom starting 2015. So I'm really proud to see that people are connected, trusted over the time the conference, and there are repetitive participants from different countries and different states in India. So thank you so very much for all this, a lot of appreciations and efforts when you submit the paper. To start with about the SmartCom, so SmartCom this year has received almost 800 plus papers, and out of this 800 plus papers, after peer scrutiny and everything, we have selected 144 papers to be published in 2 volumes of this conference with Springer LNNS series, which is an Springer Scopus Index series. And further, out of these 144 papers, I think 20 papers are presented physically today in the physical sessions at Jaipur. And after this digital inaugural, we have approximately 15 different sessions in 2 days where digitally rest of the papers will be presented. So I thank all the authors for trusting us and contributing to this conference, because I always believe that conferences, publication is one part and networking is another part. Unfortunately, those participants who have come here have not made it to the physical conference, but still I will request all of the participants to try to utilize this digital opportunity, try to hear people in different sessions, try to network them using the chat board. Chat board will be open always as usual. So please try to connect with one another. Just two important thing I would like to quote here, that there are always questions asked that why publication is so necessary and why authors should publish. There are some people in India, they say that in a PhD it's mandatory for publication, Scopus publication, so that's the reason they publish. But that is a very small part of research activity, which is not a mandatory thing, but you can say some guidelines are there, so people are doing that. But why still publication is necessary? Because anything you research, you have contributed a lot of time to that, then only you have come to a conclusion in that paper. And with this digital scenario and digital words, data has become so valued and so important in every aspect. So any data or any data analytics, even if you are doing and you are not securing that in any form, maybe in form of an idea, in form of patents, research in form of publication, it is worthless. Otherwise, it will become worthless. So publication in this scenario in today's world is so necessary, because to secure your own idea, your own thoughts, your own analytics, which you have done, your own research, even if you have done a small things, kindly, even if you are not publishing a paper, make it a copyright, make it a uh, you can say journal right, or anything which looks forward towards a publication and or a authorized entity. This is very I would like to quote here one more thing. There are a lot of queries by authors these days which are coming, because suppose a author submits a paper in January 2023 and the conference happens in December 2023. So there is a huge cycle time from January 23 to December 23, approximately 10 to 11 months. And there are high chances or high probability, maybe with some organizers it could happen, maybe unintentionally organizer don't want that, but it still happens. So what the authors have started doing worldwide is create a pre-pep version of your paper and submit it to some library. There are a lot of open access libraries, or your university or your college or your research department libraries, and make a pre-pep of that. That will save your authorized research or content from being compromised at any form. So these are a lot of queries we are being receiving, and internationally people have adopted this practice now. India, because of less of knowledge or less of experience with the researchers, this is not so common these days. But the scenario is saying that in India also this is very must in the coming times. So this is one suggestion that I would like to give authors, because there are even after the conference also the publication cycle time will be approximately 6 months. And suppose after 6 months it is published in June 2023, but your paper has been submitted since September 2022, so it's again 8 9 months. So it's a huge time to for any data or any content to get compromised, because it's a world of hacking and everything, you know how things are. So this is my genuine suggestion to everyone who are doing actually genuine research, that please create a pre-pap version of your paper and submit it to some open access databases which are doing that, just to create in repository. And I wish that you will gather more information during the sessions, and will support the participants in their presentation and try to connect with them. With this, I wish all the authors a very high deliberations time in the 2 days. And I welcome our all of the guests, Dr. Zhang, Dr. Tuba, Dr. Narendra, Dr. Nilanjan. I welcome you all, Dr. Vijay Singh Rathore. I welcome you all to this inaugural session, and I hope your session or your talks will encourage students and young researchers and motivate them to do quality and qualitative research in their own research domains. Thank you so very much, and I look forward to the deliberations for 2 days. Thank you so much.
Thank you, Amit sir, for your address. And now, moving further, I would like to invite our first speaker, Dr. Nilanjan De. Dr. Nilanjan De is an associate professor in the Department of Computer Science and Engineering, Techno International, New Town, Kolkata, India. He is a visiting fellow of the University of Reading, UK. He also holds a position of adjunct professor at Ton Duc Thanh University, Ho Chi Minh City, Vietnam. He is the editor-in-chief of the International Journal of Ambient Computing and Intelligence, IGI Global. He is the series co-editor of Springer Tracks in Nature-Inspired Computing, data-intensive research series, and co-editor of Advances in Ubiquitous Sensing Applications for Healthcare. He is an associate editor of IET Image Processing and editorial board member of Complex and Intelligent Systems, Springer. Dr. Nilanjan De, welcome to the session, sir, and over to you for your further address.
Thank you very much. A very good afternoon to all of you. Thanks to come, all the speakers, Professor Tuba, Professor Londe, Professor Kothari is there, Professor Jiang is there. So lots of my old friends are also there. So as a program chair, I welcome all of you in this conference. Vijay ji is also there. So, and also wishing a great success of this conference. I think next, all the presentation, there will be a very smart presenter will present in the SMARTCOM. So nowadays, every day we are getting smarter. Now people are actually now thinking about how to be smart, because now it's a tendency that it's a 7 conference. Once we started 7 years back, and now going through the 7 years, we are getting smarter. But maybe there is a high time to think also in a negative way, a different way, that is how to get smarter, because you people all know, I think the GPT and all these things are coming into the market and they are capturing the market. So these different 8 tracks, I think, will also give the future different directions of smart computing, starting from the infrastructure, the image processing track is there, communication track is there. So I welcome all the session chairs also in this conference, and hope to see you all next year physically, maybe in Jaipur, or I don't know exactly, somewhere in India only, and SMARTCOM as 8th edition. Thank you very much.
Thank you, Dr. Day, for your kind words. And further, I would like to invite our next speaker, Professor Milan Tuba. Milan Tuba is the Vice Rector of International Relations, Sinkedunium University, Belgrade, Serbia, and was the head of the Department for Mathematical Sciences at State University of Novi Pazar and the Dean of Graduate School of Computer Science at John Naisbitt University. He is listed in the world's top 2% scientists by Stanford University in 2022 and 2021 and 2020. Professor Tuba was the principal creator of the new curricula and programs at the Faculty of Mathematics and Computer Science at the University of Belgrade and later at John Naisbitt University, where he was the founder and practically alone established a complete new school with bachelor, master, and PhD programs. His research interests include nature-inspired optimizations applied to image processing, computer networks, and neural networks. Professor Tuba is the author and co-author of more than 200 scientific papers and editor, co-editor, or member of the editorial board or scientific committee of a number of scientific journals and conferences. He is the member of ACM, IEEE, AMS, SIAM, IFNA, and IASEI. Professor Milan Tuba, welcome to the session, sir, and over to you for your further address.
Thank you very much. It is a privilege and honor and pleasure to be part of this conference. Thank you once again to organizers, Dr. Joshi, Dr. Nilanjan, Day, my old friends. And yeah, I had to put some effort to say good afternoon because it's 2 o'clock in the morning here in Texas. And again, as Dr. Joshi mentioned, besides the regular research and publishing results, these conferences are excellent opportunity for networking, for meeting people from all around the world, for exchanging ideas, establishing future collaborations. And unfortunately, once again, I am not physically present at this conference. The life somehow changed 3 years ago when it started with pandemic. I was in Jaipur last time. I cannot even remember. I think it was like yesterday, but it was before pandemic. So it was more than 3 years ago. And I still remember how good it was at that conference. And now after the pandemic, my personal situation is that I moved to United States and not even to the East or West Coast, but Texas. So I'm actually around 12 time zones from India, and it's more difficult to travel. But I always say this is the last time that we have to do it this way. Next time, I hope we'll meet finally and be able to discuss everything in person. So for all the participants and young researchers, I think it's a very good time for them, because besides the regular situation where research is progressing and we can do some contributions and publish papers and so on, last maybe 5-10 years in this area of computer science, artificial intelligence, and especially the topic of this conference, smart trends, that is artificial intelligence, new way of doing things in computer science, because computer science used to be very connected to numerical analysis, to classical engineering, where you have mathematical formulas and you have powerful computers and then you do some computations. And now with artificial intelligence, it's really very different, and the consequences are very different, because before that it was possible to construct a very good airplane in a much shorter time and so on. But now it's reaching everywhere. So for young researchers, they should be aware that there are two areas that are very good for research, very wide areas with huge number of open problems. So, you know, in some areas, sometimes there is a problem that it is difficult to find a topic for PhD thesis, topic for a research paper, and then you may spend a lot of time working on that topic. And finally, it may turn out that you don't succeed, so you have to change the topic and turn to something else. That is a regular part of research life, but it is a little bit unpleasant, especially if you are a young researcher and you have some deadlines, like for PhD thesis or tenure or something like that. Now, in these areas, it is very good because you are practically guaranteed that any topic from these areas, more than 99% of the time, it will be successful, and it will be in much shorter period of time, because it is, you know, like Wild West. Everything is open. You just run and you will find some land for you. Well, one of those topics is optimization, which is, of course, eternal topic. Everything that we do is optimization. And I will say a few words about that later. But the really revolutionary topic that is happening last couple of years is something that we can see in real life, like new ways of doing things. For example, with mobile phones, you can unlock the phone with the fingerprint, or the phone will recognize your face. You know, it's today, children are not very impressed with that. It looks normal, but actually recognizing human face is extremely difficult computing problem, and very recently it was impossible. Now every cheapest phone can do that. And then we have things like autonomous vehicles, where you can have for a couple of years very successful cars that drive in regular traffic without a driver. And again, it may seem that it is some kind of engineering, mechanical, robotical topic, but no, these things about controlling the car, this mechanical part, is really something that we saw a long time ago. What is important is the decision-making system. Replacing driver is not so much turning the wheel, the steering wheel, or pressing the accelerator or brakes. It's about making decision about the traffic, what is around you and what action to do. Did you recognize pedestrian? Did you recognize another vehicle, bicycle? How to deal with that? Then, of course, in medicine, we have diagnostics that is much, much better than a couple of years ago, again, thanks to the same. So these are very different topics, but they all have the common research background, and that is artificial intelligence, and especially it is a classification problem, where classification problem, if you look at the definition, is a simple definition, and it doesn't look that it has to do anything with medical diagnostics or self-driving cars. We simply have a number of entities with certain features. And now, based on those features, we have to classify those entities as belonging to a certain class or not belonging to that class. So, you know, you can have, I don't know, patients, and then based on certain features. Before that, it were simple features like old-fashioned physician would look at the skin, nails, tongue, do some palpation, some kind of listening to the heart and things like that. And based on those features, they would make diagnosis. They don't care what is the name of the patient, what is the shoe size or something like that. So there are features that are irrelevant and there are features that are relevant. And before, we were limited with the human factor there, and we had to use a limited number of features and make some kind of decision. Driving a car is similar things, but here we have usually cameras, front, rear, ultrasound, radar, visual, infrared, visual, and so on. And based on those images, you have to analyze images. It is much more difficult. And then you have to decide, do you see a pedestrian? Do you see a stop sign? And so on. And then based on that, you do the physical action. So classification problem is really the essence of all these new technologies, and smart, whatever, smart card, smart city, smart medicine, whatever is smart. And the major improvement in that area happened with the introduction of convolutional neural networks, where they actually automatize almost everything. We just feed in huge input with all the features, without any special selection, with the features that may look relevant, irrelevant. You just collect everything about the environment, and then the neural network, of course, using significant computing power, will make a network that will do the classification, and it will do it today better than human experts in most areas. So that is area where there are infinite number of problems. Any young researchers can select a topic that has in it essence classification problem. Now you can work in the area of autonomous vehicles or medical diagnostics or security systems or whatever. So it can be very diverse, and you can deal with different parts of the physical world and human life and so on. But in essence, we are all dealing with the same theoretical problem, classification problem in artificial intelligence, and we are using convolutional neural network for that. So if you become expert in using convolutional neural networks, you can do anything practically in life. You can select any areas, and as I say, practically whatever you touch, you will be able to improve it and make it better, because it is very new and very powerful technology. And then within convolutional neural networks, there is a problem of the architecture of that network. How many layers, how many connections, and many other parameters, where that is a hard optimization problem. So then again, we get together those two problems. Optimization problem, hard optimization problem is another area where also there are numerous new artificial intelligence methods for optimization, and also many opportunities to do research. Now, combining those two fruitful areas really gives opportunities to researchers to be very successful. So I wish all the participants all the best and success. And I hope that there will be a lot of networking and many future collaborations will be established. And that we can, even though there are many problems in the world, this area, research area, really looks without problems. It's very promising. It's pleasure to be in that area where you really can give your contribution. So once again, all the best to participants. Thanks to the organizer, and I wish you a pleasant time in this conference. Thank you.
Thank you, Professor Tuba, for your knowledgeable address. And we hope to see you in our physical conference soon. Now, I would like to invite our next speaker, Dr. Yu Dong Zhang. Yu Dong Zhang received the PhD degree from Southeast University, Nanjing, China, in 2010. From 2010 to 2012, he worked as a postdoctoral researcher with Columbia University, New York. From 2012 to 2013, he was an assistant research scientist with RFMH, New York. From 2013 to 2017, he served as a full professor with Nanjing Normal University, Nanjing, China. He currently serves as a professor with the University of Leicester, UK. His research interests include deep learning and medical image analysis. Dr. Yu Dong Zhang, welcome to the session, sir, and over to you for your further address.
Okay, thanks, Anisha. Can you hear my voice?
Yes, sir, we can hear your voice.
Okay, I think it's the third time I will invite you into this inaugural talk for the SMARTCOM. I have been into many conferences with the SMART or the communication themes. But personally, I believe SMARTCOM is one of the best sites for the researchers, for the networking, because it provides a mix of both the training and the communication, the networking, and the researching and the teaching things together. And particularly, I remember that this year is the seventh conference, and that will be held at the Jaipur, India. And sorry, I can't be there in person. Because I was notified like this event just several days ago. But I do wish the participants you will learn something from this conference. And I remember several years ago, once the SMARTCOM was in UK, I have been there in person, and it's a very good and beautiful thing to listen to the keynote talks and to listen to all the presentations. And particularly, it is important for the networking, because this conference can link you to the most smartest people. Particularly, I will suggest that it is always good to connect with Professor Roshi, who is one of the best AI experts in India. And thanks, Professor Amit Roshi. I will leave it back to you. Thank you.
Thank you, sir, for your address. And now I would like to invite our next speaker, Dr. Narendra Londe. Professor Narendra Londe is presently working as an associate professor in the Department of Electrical Engineering of National Institute of Technology, Jaipur, Chhattisgarh, India. He has 14 years of rich experience in academics and research. He has published more than 150 articles in recognized journals, conferences, and books. His main area of research includes medical signal and image processing, biomedical instrumentation, speech signal processing, biometrics, intelligent healthcare, brain-computer interface, artificial intelligence, and pattern recognition. He has been awarded by organizations like Taiwan Society of Ultrasound in Medicine, Ultrasonics Society of India, and NIT Raipur. He is an active member of different recognized societies from his areas of research, including senior membership of IEEE. Dr. Narendra Londe, welcome to the session, sir. And now over to you for your further address.
Thank you, Anisha. Anisha, I would like to share a screen just to have some showcase on my small presentation that I have prepared for this conference, right? Basically, when I thought about the theme of the conference, I just come across my own work that I have, which is related to computing and communication as well. As all of you know that there is some communication devices required where the people are bedridden. They are having the neurological cognitive abilities, but they are not having the muscular abilities, and that is why they are not able to communicate with the outer world. And treating such patients or communicating with such patient becomes difficult. Okay, and that is why there is a P300 speller. Basically, it is an EEG based speller. It actually converts the brain signals into the text. That is what we have developed, but we have developed it exclusively for the Indian population, basically because we have designed it for the Devanagari script. Most of the Indian languages like Hindi, Marathi, Maithili, all these languages are they use Devanagari script to write those languages. So we have taking into consideration the largest population of India. We have developed this P300 speller for the Indian population. What exactly it has in it? Okay, you can see here there is a one display. This is one display that this display is here. There are some numerical, there are some alphabets that those are flashing over there. So this flashing is row wise and column wise. So the first rows will be flash and then columns will flash. The user will look at those columns and rows flashings, and whenever he strikes at the target character, that character after that target character in the EEG signal, after 300 milliseconds of time, it will generate a positive magnitude of which it will not be able to produce for other characters. So that is how, based on that P300, we are able to find out that what character that particular person is looking at. And we are then, after that character detection, then we are converting it into the words also. Means concatenating all those characters and forming a word. So this is what the system that we have developed. We have almost spent around 8 years of time developing this. Okay, so this is basically a device which actually converts the cognitive response into the text. You can see this is how this P300 signals are generally look like. If you are seeing here that the magnitude at this particular are almost around at 300 milliseconds of the latency, it will be having the highest magnitude, and at rest of the places the magnitude may be there because of the disturbances, but its magnitude will be less. So with the help of this, we are able to communicate with the patients suffering from the neuromuscular disorders. What is this P300? As I told you, it is a positive magnitude, and it is appearing in the EEG signals after 300 milliseconds of the excitation. So when you are looking at the target character, that is your visual excitation that you have received, and after 300 milliseconds, that particular positive magnitude will generate, right? And in order to find out that what exactly this positive magnitude or P300 signal is talking about which character, we have developed, we are used an oddball principle based on which that character has been detected. What is oddball principle? Basically, if you are flashing the frequent events in between the rare events, okay, so that rare events will be automatically get detected by the P300 signal. That is how this oddball principle works out. This cognitive, this particular P300 spellers As I told you that it generates only it is based on the P300 signals, which is having the positive magnitude at around 300 milliseconds. That is why it is called as P300, right? Now, this is the display that we have designed. This is the first time that we are the first team that we have designed this thing, this particular display, this particular P300 speller, and you can see these all alphabets are representing the Devanagari script, right? Now, in the Devanagari script or in the Indian languages, there is whatever the languages that are being spoken with the Devanagari script, they are basically having two difficult things. First one thing is that there is a matra, and second thing is the joining of the alphabets, joint alphabets. So that is why we have taken up three more here. You can see there is a hash here. That hash we are using here as a special character to provide that matra and the connected words. So you can see here in this example, if I'm not putting the hash signal here, then it will be this V and A that is forming a matra here. So the Y. So this is becoming a matra here. While in this case, when I'm using the hash here, you can see I'm using here hash and then R. Then what will happen? This R will get and join with this G. That is how it has joined here and forming a Gr, right? So this is how we have solved the biggest problem of joint akshars and the matras in the Indian languages. This is how that we have flashed those rows and columns, and accordingly those EEG signals has been recorded. As you can see in this image, this flashing is being performed here on the screen, and with the help of this EEG machine, EEG cap, this EEG cap output signals are connected to this amplifier, and that amplifier signals are being taken to the computer where it is being stored, and thereafter it is being used to find out the characters what has been the particular user looking at. Okay, so out of this work, almost in this last 8 years, we have published some benchmark results in these 9 publications. I will just tell you about what exactly was that in those publications. Basically, in this particular P300 system, as I have shown you here, that it has up to EEG recording, it is okay. Now here the computing starts, that the classification of the P300, that in the EEG signal, we have to find out where is the P300. Once I find out that P300, I have to find out that in that P300 belongs to which character. Once I find that character, then I can club all those characters, all the characters, and find a word. So for that, we have covered all these phases of the speller in all these our studies. So that is what I have shown you here, that for the classification, we have done it in publication 1 by SVM, ANN, KNN, SW, LDA. Then P2 to P4, we have used deep learning based weighted ensemble based of SVM. Then we have used from P1 of P5 to P7, we have used deep CNN, stacked auto encoder, weighted ensemble DCNN, compact CNN. Then for character detection also, we have used conventional maximum probability of intersection of row and column based methods, and we also used channel dropout based methods. For the word prediction, we have used weighted edit distance based spelling correction method that already your mobile systems have. Based on that, we have used this word prediction system. Then finally, very recently, we also have added the knowledge distillation and transfer learning so that we can improvise the classification of this P300 by adjusting the trade-off between the parameters, system parameters, and the performance. So I will quickly go through that, how this in all over these papers, whatever the methods that we have implemented for the classification of P300, how they have performed. They have performed. These are, if I will just not go into the conventional machine learning, I will go only into the deep learning. So these are the parameters. These are the accuracy. With this accuracy, we are able to find out Then this is the ITR, information transfer rate, that also we have calculated for the comparison. And you can see here in this deep learning methods, gradually when we have moved from DCNN to MDCNN, then weighted ensemble DCNN, then shallow DCNN, then EEG-net, then compact CNN. That is how we have moved from one deep network to another network. And finally, you people can observe here that the number of parameters has been reduced very much. And we could, this one, you can see these numbers 1, 3, 5, 15. This is nothing but the flashings. This is nothing but the trials. What trial means? As I told you that all the rows and columns will flash. So as I have shown you that my matrix is of that display is having the matrix of 8 by 8 characters. So total there will be 16 flashes, right? 8 rows and 8 columns. So that one is complete one trial. So people are able to get the higher performance with the higher number of trials. But in that cases, the time to compute a single character is very high. That is why we are the first team that we are able to crack all this detection of the character in a single trial, and that too with such a higher accuracy of 83.73%. And if I go with the higher trials, then even it is reaching to 95.32%. Likewise, we also have done the channel selection, say that all that whatever the cap that you are wearing on your head for the acquisition of that EEG is not all that electrodes are contributing, or all that channels are not contributing towards the detection of your characters, right? So what we have done, we also have applied the channel selection, which actually eases your calculation, right? See, as you will handle large data, then the computational time will be very high, and to detect a single character, say that I am looking at one character, already it is taking 300 seconds to come that character into my EEG signal. Once it comes into my EEG signal, and then I am applying my computing and taking too much of time, and then I am able to say that yes, you have looked at, say, character okay. So if that is around 2 to 3 minutes of time it is consuming if I'm doing it with the 15 number of trials. So that is why we have reduced that number of trials first, and secondly, then we have also reduced the data that we are processing with the help of the channel selection. You can see here we have used optimization methods, single objective binary differential equation method in 2 of our publication, P2 to P4, right? You can see these are the accuracies and these are the number of channels that we have reduced. Okay, so accuracy has been almost around 76%, 87%, 92% with the higher number of trials. Yes, if you are giving a higher number of trials, the person will get practiced and he is able to perform very well. But we have to see that that number of practice or that number of computing will be taking larger amount of time. Okay, so what we did, we have used our deep networks, and in that, with the help of the channel wise convolution and the channel mix depth convolution, we are able to reduce these channels from 8, 6 and 5, right? You can see here the number of channels. These are in decimals, but that can be round off because that is a calculation. Because of calculation, it is coming as 26.1, but you can say that it is 26 channels. So this experiment was performed for 64 channel EEG cap, while this experiment was performed for 16 channel cap, and we are able to reduce that number of channels to only 5. So that is the advantage. That is what the progress that we have arrived into this our experiment. We also have used, as I told you, word prediction. We have used weighted edit distance approach, right? And in this, we have taken all these 10 subjects data. We have used 5 number of trials, 10 number of trials, 15 number of trials, and we have given them total 100 words, right? And out of that 100 words, when I'm using my basic system, then my performance is like out of that 100 with 5 number of trials, I'm able to get 21 correct words, 45 correct words, or 56 correct words maximum. If I go with my another version of the speller, I am able to get 65 max. Then I used to edit distance method. I am able to get 87 correct words. I am able to predict. And when I used, we have further improvised it and used the weighted edit distance method. You can see here the results are very encouraging. That with the 5 number of trials, we are able to predict 83 words correctly and 97 words correctly with the 10 number of trials, and 99 words out of 100 with the 15 number of trials. Likewise, as I told you, that knowledge distillation and transfer learning we have used in our one of the publication, last publication P9, and there we have used all these networks, DCNN, shallow CNN, EGNet with transfer learning, without transfer learning, and these are the 3 compact CNNs that we have developed for our own, customized for our own data. And you can see with that the the P300 classification has improved so high, so heavily. You can see that almost 95.32% accuracy we are able to achieve with only 4553 number of parameters, 4553 parameters, and that too in a single trial. So if I see anything that if you want to use, it should be a real time. Say that if that patient is looking at the character at one character, right? The recognition of that character should happen immediately within a 2 or 3 seconds of time. Likewise, then the communication is possible. So now we are able to detect these characters in only 2.3 seconds of time in a single trial. Okay, so that is how we have developed this. Almost 8 years has been spent on this, and we are still doing. We are already has improved this, and it is under now a patent with the Indian Patent Office, right? So thank you once again for. I thank the organizers of the conference, Dr. Amit Joshi, Dr. Nilanjan Dey, for inviting me to this inaugural session and giving me a chance to share this particular my work and to share the dais with such a dignitaries here today. Thank you so much. I wish all the participants a great success at SMARTCOM 2023.
Thank you so much, sir, for your knowledgeable presentation. And we can say that P300 wave is an event-related potential ERP component elicited in the process of decision making also.
Right.
So now moving further, I would like to invite our next speaker, Dr. Vijay Singh Rathore. Dr. Vijay Singh Rathore is a professor, CSE, and director of Outreach, Jaipur Engineering College and Research Center, India, and secretary, ACM Jaipur chapter, and past chairman, CSI Jaipur chapter, having teaching experience of 20+ years. His core research areas include internet security, cloud computing, big data, and IoT. He has organized and participated 25+ national and international conferences of repute. Dr. Vijay Singh Rathore, welcome to the session, sir. And now over to you for your further address.
Good afternoon, one and all. Am I audible?
Yes, sir, you are audible.
So I'm logging in with the ID of Amit Joshi ji because there is some network issue in my computer. So I am here to give my vote of thanks, and I'd like to say thanks to all the participants, audience, and the speakers who spared their time and they came here online itself. In the morning we had offline session. It was very amazing, very nice, and people were participating with the enthusiasm. And here also we can see a lot of people are there online and they are attending the session from the beginning. So thank you so much to all of you. Special thanks to Professor Milan Tuba, Professor Narendra, Professor Nilanjan Dey, and the Professor Jang and Mr. Amit Joshi for providing such a fruitful knowledge to the audience. And we hope that this conference will be beneficial to the participants as well as the researchers to get new ideas and to distribute their knowledge to improve the research, whatever they are going on. So thank you so much to one and all to be here. And we hope to meet next time one-on-one physically also, especially Mr. Narendra and Professor Jhang. We have not met so far. So I'd like to see you in the next conference physically also. And Professor Milan Tuba, we hope to host you in February also in Jaipur. If you can spare some time, it's my special request. We have not received your confirmation so far. So we hope that we'll get it within 1 or 2 days. So see you there, sir, Nilanjan Day. See you also at this Ice Teas in Jaipur in the next month. So with that, thank you so much to all of you for sparing your time, being online and listening patiently. Thank you so much to one and all. Namaskar.
Thank you so much, sir, for your address. And it was a sheer joy for all of us to listen to the speakers. And we thank you all for your valuable presence. And we hope to see you all again in our upcoming conferences. Now that we have come to an end of the inaugural session and we have different technical sessions planned for the day, I request all the participants who have been attending the session over the time to kindly attend those sessions. Further, it's a request to all the participants to join the technical sessions as per the schedule. The timing for the technical session 1A is 3 to 4:30 p.m. and for the technical session 2A is 5 to 6:30 p.m. Further, I sincerely thank everyone for their valuable presence in this session, and it is our pleasure to have you all here with us, and we will be happy to have you in the 8th version of the conference in 2024 in physical mode. Now I request you all to please switch on your cameras for a snapshot of this virtual session. Okay, thank you so much, everyone. Stay safe and take care.
Thank you so much, everyone, from my side as well. And I look forward to see you, all of you, very soon in person for the next conferences. Thank you, Dr. Narendra, Dr.
Thank you, sir. Thank you, everyone.